Hey, great morning here, friends. We are here to finish up Chapter 1. We have Section 8. We're going to look at an introduction to functions today. We're going to begin with talking about the XY coordinate plane, plotting a few points, and then ending up with using an XY table to um, plot points to represent functions. So let's begin with the xy coordinate plane. Why it's called the xy coordinate plane is there are two axes. We have the horizontal left and right axis known as the x-axis, the vertical up and down axis known as the y-axis. These axes intersect, cross at my center of the universe for the xy coordinate plane, known as the origin. That's where I originate or start. The graph area here, the coordinate plane, is broken down into four areas known as quadrants. The upper right quadrant is known as quadrant 1. For whatever reason, historically, Roman numerals have been used. So I is Roman numeral 1. Upper left is quadrant 2. Double I. Lower left is quadrant 3. Triple I. And lower right is quadrant 4. Other parts on our xy coordinate plane here, we are going to look at plotting ordered pairs in the format x comma y inside parentheses. So I'm going to be given an x value first. If the x value is positive, that means I am going to move from the origin to the right. So I'm going to go right on the x-axis. If the x number is negative, I'm going to move to the left. Then I'm going to be given a y number after the comma. If that y number is positive, I'm going to move up. And if that y number, the second number in the ordered pair, is negative, I'm going to move down. So if I have a ordered pair that ends up in quadrant 1, I'm going to move to the right and then up. So the x number will be positive, the y number will be positive. If I end up in quadrant 2, I'm going to have to go from the origin to the left and then up. So left would be a negative x and a positive y. Quadrant 3, I'm going to have to move left and down. So negative, negative. And then quadrant 4, I am going to go positive to the right and then down negative y. So those are the signs of my ordered pairs in each quadrant. We're going to actually take a look here at plotting the following four ordered pairs, the 4 points, on a xy coordinate plane. First point I have is 3, 5. So that tells me from the origin I'm going to go 3 to the right, take a little break, deep breath, and then up 5. So here's my origin. I'm going to go 1, 2, 3 to the right, and then up 1, 2, 3, 4, 5. So 3, 5 would be at this location. I'm just going to mark it 3, 5. Point 2, negative 2, negative 4. This tells me to go negative 2, so 2 to the left, 1, 2, and then down 1, 2, 3, 4. So 2 to the left, down 4 would be in this location. Negative 2, negative 4. Make that a little more clear. Sorry, got a little crunched for space. Third point is negative 6, 1. So I'm going to go 1, 2, 3, 4, 5, 6 to the left, and then up 1. Negative 6, 1. then finally, we're going to go with 5, negative 2. So 5 to the right, 1, 2, 3, 4, 5, down 1, down 2. 5.
Good morning, staff. Happy Monday to you.
It is a happy Monday.
Remember
Have a
today,
great day.
tomorrow, or
see you back for
picture
graphing
days,
functions.
for those of you...
All right, and we're back to finish up the last 3 examples where we are going to generate ordered pairs for each function. We are having input values, as you can see on our tables here, of negative 2, negative 1, 0, 1, and 2. How do we get those numbers? Those are given to you. Those are the 5 values that we are going to use for every function when we use what we call an XY table or a T chart. My chart here kind of looks like the letter T, so we just call that a T chart. We're going to get the 5 ordered pairs, and then we are going to sketch a graph and describe the pattern. So my first function, I'm told that y is equal to x plus 1. So I'm going to plug in these 5 values for x, negative 2, negative 1, 0, 1, and 2, and then figure out what my y value would be. So if I plug in negative 2 for x, y would equal x is negative 2 plus 1. Negative 2 plus 1 is negative 1. If I plug in negative 1 for x, negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So I'm going to take a little quick sketch here and plot the given ordered pair. So negative 2, negative 1 is 2 to the left, down 1. Negative 1, 0 is 1 to the left, nowhere left or right. 0, 1, 0 for the x-axis means stay at the origin, go nowhere left or right, and then up 1. 1, 2, 1 to the right, up 2. 2 to the right, up 3. So if I look at connecting these points, the format or shape of this graph would be a line. This is a linear function. So we would call this a line. Taking a look at example 2, we have an absolute value function. So I am going to take the absolute value of negative 2, which is 2. Negative 2 times 2 is negative 4. Negative 1 I'm going to plug in for x. Absolute value of negative 1 is 1. And then negative 2 times 1 is negative 2. Absolute value of 0 is 0. Negative 2 times 0 is 0. Absolute value of 1 is 1. Negative 2 times 1 is negative 2. You might say, whoa, I already used negative 2. Okay, believe me, trust me on this. Absolute value of 2 is 2. Negative 2 times 2 is negative 4. You're going to see how this works out in the pattern or shape of the graph here. Quick sketch of my xy coordinate plane. Negative 2, negative 4 is 2 to the left, down 1, down 2, down 3, down 4. Negative 1, negative 2, 1 to the left, down 2. 0, 0. 1, negative 2 is 1 to the right, down 2. And then 2 to the right, down 4. So if I were to connect these points, this would be kind of like an upside down V. Or if you just say it's V-shaped, that's totally fine too. So if you have an absolute value in your function, you're going to have either an upside down V or just a regular V. The last type of function we're going to look at is when we have a variable squared. So I'm going to plug in -2 for x. So y equals 1/2 times -2 squared. So remember, with order of operations, I have to go parentheses, then exponents. So 1/2, and then -2 squared is +4. I'm taking -2 times itself, which is +4. Half of 4 is 2. Now I'm going to plug in -1 for x. So -1 squared, -1 times itself is 1. Half of 1 is 1/2, 0.5. 0 squared is 0. Half of 0 is 0. If I plug in 1 for x, 1 squared is 1. Half of 1 is 1/2. So you can see here we have this symmetry going again. If I plug in 2 for x, 2 squared is 4. Half of 4 is 2. So I have my 5 ordered pairs here. I'm going to sketch a graph. -2, 2 is 2 to the left, up 2. -1.5, 1 to the left, up 1/2. 0, 0, 1 to the right, up 1/2. And then 2 to the right, up 2. So as you see here, if you try to connect these with a straight line, it's not going to work. So we need to put a little curve on my graph here. And my graph is going to take more of a rounded U shape. We're going to look later on this year and discuss these U-shaped graphs when we have squared functions, and the technical term for this shape is a parabola. That's the algebraic definition of this graph shape, this U-shaped. It's a parabola. If you say parabola, you have the emphasis on the wrong syllable. So yes, parabola. We've got our 3 types of functions we'll look at graphing today. Get them out, graph them up, light them up, blow them up. Have a great day. Fly on.